Hello, I'm Simi Saleko.
I'm Jimmy Saleko.
And I'm Sienna Stuckey.
And we are Berkeley High School Team B. Today we will be presenting a demo show entitled How to Create Electricity Through the Use of Voltaic Cells. Here we have the simplest battery that we will be presenting today. And here we have two metals on a piece of plywood. We have zinc metal and copper metal. As you can see, even though these metals are attached to the voltmeter, there's still a reading of 0 volts. This is because even though there's a redox reaction going on, with zinc oxidizing and copper reducing, there's still no salt bridge, which helps with the loss of ions. Here, the human body will be acting as a salt bridge. As you can see, when combining the copper metal with another piece of copper metal, we still get a reading of 0. This is because even though I'm connecting it and I'm acting as a salt bridge, they're the same metal, so they have a 0 potential difference. And potential difference is just another word for voltage. However, when combining the zinc metal with the copper metal, we get a reading of 0.3 volts. This is because they're different metals and have a different potential difference.
Over here we have a lemon battery. In a lemon battery, instead of using a hand, the lemon is acting as a salt bridge. Here we have a zinc metal and a copper metal. And after attaching them to a voltmeter, the voltage should be around 0.93 volts. This is because the lemon has citric acid, which partially dissociates, causing electrolytes to be in the lemon, and these electrolytes form a salt bridge.
In the third part of our experiment, we use these two solutions and a salt bridge at 25 degrees Celsius and an atmospheric pressure of 1 atm. This solution is copper 2 sulfate, and this solution is zinc sulfate. When we insert zinc metal into the zinc sulfate solution and the copper metal into the copper 2 sulfate solution, we receive a reading of 0.0. This is because there is no potential difference between the two solutions. When we add a salt bridge containing potassium nitrate, because it is soluble in water and does not leave a precipitate, we receive a reading of almost 1.1. The reason we receive this reading is because two metals from the zinc plate are being released into the zinc sulfate solution and are being transferred through the salt bridge to the copper 2 sulfate solution and are then being taken up by the copper plate. In this reaction, the zinc metal is oxidized and the copper metal is reduced. The ions in the salt bridge compensate for the loss of ions in the two solutions.
Well, as we've seen here in the first battery, we used a hand as the salt bridge and get a reading of around 0.3.
In this lemon battery, we have the lemon acts as a salt bridge and has a voltage of 0.9.
And in this reaction, we have a salt bridge acting as a salt bridge and gives us a reading of around 1.1.
And we hope that you found this presentation electrifying.